word transformation is a very general term. It covers a lot of different transformations. We're going to go on and talk about, throughout this unit, we're going to talk about 4 very specific transformations. And they're going to have another subcategory called isometries. And we'll talk about them very specifically. But you just need to understand that transformation is any change. Maybe I flip it over, maybe I rotate it a tiny bit, maybe I make it a lot bigger than the other one. Okay? Anything you do to a figure that changes it to another figure, okay, is a transformation. It's very general. So in this first one here, right here, let me get my pen going. This one to this one, what's happening is it's just flipped over, right? Probably over some line in here, right? It's reflected over that line. This one here, I don't know about you, but to me, this one looks a little smaller, doesn't it? Maybe it isn't, but it looks a little smaller. If not, then it for sure is moved from this location to this location. Okay? And this one here actually looks like a couple things were done to it. It was flipped over, and it was moved, right? I mean, we didn't just flip it over this way. We flipped it over this way, and then we slid it up, right, to get over here. So a couple things have happened to that one. Here it says the figure turns. That's not true. That's what I thought at first also, but oh, I guess it is true if these are the same length, those two sides. I suppose it could just be rotated one turn this way. It didn't look that way to me at first. Okay. So it isn't real obvious to me, but I agree it could be just a rotation there. Okay? The original figure is called the preimage, and the resulting is the image. Isometry is a transformation in which the preimage and image are congruent. Each transformation above is an isometry. Okay? So what they're saying is, remember I said this one looks smaller to me? We're saying it's not smaller. They're exactly the same size. Sometimes it's difficult for me to see things on the board. It's a little too big. I need to back away to see it better, and I can't do that for you guys. I'll cover the rest of the room. But to me, this side looked longer than this side at first, and this side looked longer than that side. To me, that looked something strange at first. Okay? And I see if I back away from it that I certainly agree that that could easily be a rotation. And that was my intent. Put it on. Pre-image, image. When you look in the mirror, what do you see? Yourself, and what do you call that? Your reflection. Another word for it is your image. Okay? When you look in the mirror, you don't see you, you see your image. Right? fix anything? Alright? So when you look in the mirror, you see your image. Another interesting thing about that, your image doesn't look like it's on the face of the mirror, does it? It looks like it's back behind it, right? When you look in there, you're not right here. You look like you're back here, right? You know how far back into the mirror you are? You want to take a guess? When you look into the mirror, how far away do you think that your image is? Exactly. Nice job, Amber. How far is your nose from the mirror? Let's say it's a foot away. Then in your image, you're going to be a foot away. Okay? So what we're saying here, find a place to draw. We'll copy those down in a second. All right, so here's your face, here's your mirror. Your image is going to be the same distance. Over here, now you have an unibrow going. Okay? Anyway, this distance from here to there is going to equal that distance from there to there. Okay? I just drew that freehand. It's not going to be exactly the same, but I wanted to actually was only doing that for the video because the recording because they can't see what we're doing out in the room. They can see what's written on the board and they can hear what we say, but things out here they can't see. So this distance from here to there is going to equal this distance from, so the pre-image to the reflection line is going to equal the distance from the reflection line to the image. Okay? So you are the pre-image, you're before it's reflected, and your reflection is called the image. Alright? So in this picture here, we have three of them here. And these first two, the blue ones, are and this one, the blue ones are the pre-image, and the red ones are the image. Okay? This one looks like a simple reflection over a line right through here. This one's definitely not the same size, right? So that one's being expanded. Is that an isometry? What did we write for isometry? Can someone tell me what we wrote?
Isometry was the same.
Louder, please. I can't hear you with the fan.
Isometry was like the same size.
Yeah, they are going to be the same size and the same shape. Okay? They're just going to be placed somewhere else. They're rotated, slid, reflected, or a combination of them. Okay? And then this one here. Now the blue one is actually the image and the black one is the pre-image. I can know that because of the little marks next to the letters. We read this as K prime, J prime, Q prime. Okay? And so this is triangle JKQ, and this would be triangle J prime, K prime, Q prime. Right? And this symbol here is red, maps onto. Okay? That's why I wrote that there. So you can see how to read that symbol. So triangle JKQ maps onto triangle J prime, Q prime, I'm sorry, J prime, K prime, Q prime. And so probably it's going to be some reflection over that line right about there. Okay? And what do we say about the distance from this point? Oops, sorry. From this point here, and this line. What's the relationship between them? Sorry, I just couldn't hear you guys at all. I know you're all answering. What's the relationship between this point, and this line?
Would it be like the same long distance from the dot to the line?
Very good. You probably didn't hear that at home, but Emily just said the distance from K to the line is going to equal the distance from K prime to the line. So those distances are going to be equal. Okay? By the way, if I have something like this, and the distance from A to B is equal to the distance from B to C, then we put a little mark there like that. That means they're equal. Or if I already have a single mark somewhere else in the picture, I can put 2 marks there. Or if I already have 2 marks somewhere else in the picture, I can put 3 marks or 4 marks or whatever. But those equal number tick marks mean that those distances are equal. Okay? All right. So any questions on this slide? Key points to make sure we understand. An isometry, the transformation, which the pre-image and image are congruent. Okay? That's really important. The pre-image and image are congruent. So an isometry always maps the pre-image onto the image. Alright? It always maps the pre-image onto the image. And if I did that, and I held it up to the light, okay, they'd be exactly the same. Okay? I might have to rotate them around. Alright? I might have to flip them over. I might have to slide them. I might have to do a combination of those things. But ultimately, I can put one of them right on top of the other one, just like my hands. Ignore my broken finger that shoots off to the side. You take my hands and put them on top of each other. My right hand maps onto my left hand, right? They're exactly the same. And that's what's happening here in an isometry. It maps one right onto the other. Okay? Last chance. Any questions on that? Okay, reflection. Or flip. I never call it a flip. I might say a reflection flips an image over a line and okay. But here's some very specific facts about reflections. I'm going to pause this so that we don't record all this airtime, and then we'll get it all copied down, then we'll go back through it. A reflection is an isometry in which a figure and its image have opposite orientations. Okay? They have opposite orientations. So what we mean by that, if I draw this triangle, I call it ABC, and I have some line here that I'm reflecting over. This would be A prime, B prime, C prime. Okay? As I read ABC, I'm going counterclockwise, right? You guys understand what counterclockwise means? I ask that because so many of you are in the digital world and you've never spent any time looking at a clock. But as the clock hand goes around the clock, it goes this way, right? That's clockwise. And so this is the opposite direction, so it's counterclockwise. Okay? So I read this as triangle ABC. This reflection maps that onto triangle A prime, B prime, C prime. And as I read A prime, B prime, C prime, it's clockwise, isn't it? So this one is counterclockwise, and this one is clockwise. So they have opposite orientations. Okay? That's what we mean by opposite orientations. Emily's gotten too much mirror time. Touch your right ear. Does it look like your right ear in the mirror? Looks like your left ear, doesn't it? Okay? That's why when you look in the mirror, everything's backwards. That's why when I try to trim the back of my neck after I've cut my own hair, I'm looking in the mirror and I've got things going on and I'm here like this and trying to get my trimmers turned just right, and I turn them to the right and they should have gone to the left. That's why it's so difficult to do, because everything is reversed on you. So when you look in the mirror, when you do a reflection, it's going to reverse or change the orientation. Okay, and orientation means the order in which it lines up. Okay, so using the diagram below, a reflection in line R is a transformation for which the following are true. Let me move this out of the way. And get rid of our pop too. Alright. So, what else is true? If a point A is on the line R, the reflection line R, then the image of A is A. So if the point is on the line, when I reflect it, it's going to stay on the line. Alright? So if a point's on the line and you reflect it, it's going to stay on the line. If point B is not on the line R, then R is the perpendicular bisector of segment B, B prime. So we're saying this is B, this is B prime. Here's the segment, B, B prime. And so this reflection line is going to be perpendicular, that makes this 90 degrees, and it's going to bisect this segment, meaning it cuts it into two equal pieces. Okay? Cuts it into two equal pieces. So that's what perpendicular bisector means. You can use these properties to find and draw reflection images. Okay? So, let's practice one. Let me pause this for a second. To tell me to turn this back on. Sorry about that. Hunter, if you're at home wanting to look at this. So what we're doing, just to recap, we just measured, we made sure this was 90 degrees, so perpendicular. And then we put a ruler up there. We measured that point. We got 3.9 units to the line from point C. We move this out of the way and we marked 7.8 units. And what is this going to be labeled? C. Nice and loud. Can I call it C? Is it the same point as C? No, it's C's image, right? So how do we label that? C prime. That's right, C prime. Okay? So now, I want to move A. Well, I need a little bigger protractor. So I put my protractor on 90 again. Can't see this, but can't see where my finger's at home. But you'll see the 90 is on the line, and this right here is on the line. I just draw a line. Okay? And so if I move my ruler up to there, I get really close to 10.5. It's probably 10.45. Okay? And since I don't have enough ruler to just go add that to itself, I'm going to move over. And I'm going to go 10.45. It's like right there. Okay? So there's What's that point? A prime. Okay? That's A prime. If I slide this back down, I can measure how far B is away. Look at that, same distance, 10.45. Come over here. 10.45 is like right in there. And what's that going to be marked as? What do we mark that as? Come on, nice and loud. B prime. Then I can draw my lines. And I have just reflected triangle ABC over line, whatever I label it. And I now have A prime, B prime, C prime. Okay? Now I do have little reflecta things called reflectas or mirrors I mean. And we can do it a little different way, but the reason I want you to do a few of these this way is I want you to understand the rules that go along with a reflection. I want you to understand that they're the same distance apart. And I want you to understand that they're perpendicular to the reflection line. Okay? This line here is perpendicular to this line here. Alright? So I need you to understand those two things. Okay. It's taken a lot of time. I normally don't try to take this much time, but we also had to talk about a few things. Let me pause. Very short. Three to 21 by 3s. That means you're going to do number 3, number 6, number 9, number 12. There's only 7 of them. Okay. Someone asked if you can do your homework on your notes. You sure can. You sure can, because anytime I'd allow you to have your notes, I'd allow you to use your homework. Alright, so you can do them together if you want, or you can do them separate. You know, that's up to you. Make sure you identify what lesson it is, and make sure you identify who you are. Oh, I'm sorry. It's lesson 12.1. It's around page 637. 636 and 637. Okay? I thought I hit record here. I guess I forgot. But you have to know these lines in order to do a few of the problems at the end.